right, let's look how to sketch another one. This one's going to look a little different than the other graph, but we're going to go through these same procedures. All right, so let's do this. Let's, step one, factor everything. So I'm going to have f of x equals 4x over x plus 1 minus 1. All right, well, nothing comes out of this. This can't be reduced. Therefore, I have no holes, so no holes are not applicable. But I do have vertical asymptote. So I know that x plus 1 cannot equal 0, minus 1 cannot equal 0. Therefore, x cannot equal negative 1. X cannot equal 1. All right, we have to do our tables. Well, I'll write them over here as we find them. We're going to do the limit as x approaches negative 1 from the left of f of x. We're going to do limit as x approaches negative 1 from the right of f of x. We're going to do the limit as x approaches 1 from the left of f of x. We're going to do the limit as x approaches 1 from the right of f of x. Each of these are a table. All right, so we're going negative 1 from the left. It's going to be negative 1.1, negative 1.01, negative 1.001. This will be negative 0.9, negative 0.99, negative 0.999 coming from the right of negative 1. Coming from the left of 1 is 0.9, 0.99, 0.999. Coming from the right is going to be 1.1, 1.01, and 1.001. Take each of these values, plug it into here, and see what number you get. That's what you have to do on each one of these. But you'll start noticing a pattern as you do more and more and more of these. This is going to be negative 21, negative 201, negative 2001. So this tells me this is going to go to negative infinity because it's going down forever. And at negative 0.9, I've got 199, nope, 199, and 1,909. Now these are all rounded numbers. So this is telling me this one's going to infinity. Here, there's some symmetry to this graph, so this is going to be 19, 109. These are negative, and a negative 1,999. So this is going to negative infinity. And this one matches up with these, except the signs change. This becomes 1 in 1,001. It doesn't always work out this way. So just make sure you're taking each of these and plugging them in and actually getting an approximation so you have a rough idea what's going on. So this gives me infinity. So my vertical asymptote, when I have x equals negative 1, the limit as x approaches negative 1 from the left of my function f of x going to negative infinity, and the limit as x is approaching negative 1 from the right of f of x, that is going to be infinity. Now, when x equals 1, I have my limit as x is approaching 1 from the left of f of x, and that's going to be infinity. And I have the limit as x approaches 1 from the right of f of x. That's going to be infinity. Hopefully I didn't go off the board, which I did. So that one's going to be infinity. All right. So now we have our vertical asymptotes and our behavior around the vertical asymptotes. So let's look at horizontal asymptote. We can do this before I erase. So I'm going to go back up here. My numerator is degree 1. My denominator is degree 2. Well, my numerator is less than or smaller than my denominator because last time I checked 1 is less than 2. That means my horizontal asymptote is going to be y equals 0 or the x-axis. So all I have left to do to figure out this graph is the x and the y-intercept. Well, these are actually going to be pretty easy to do. So before I erase, let's find the x and y-intercept. To find the x-intercept, we set the numerator equal to 0. So I have 4x equals 0. Therefore, x equals 0. We're going to divide by 4. So my x-intercept is going to be 0, 0. Well, I don't even have to do anything for the y-intercept because 0, 0 is the only point that can be an x and a y-intercept on the xy plane or the Cartesian plane. But you can put 0 in everywhere and you will get 0 over -1, which just becomes 0 divided by -1, which is just 0. So it's 0, 0. So now I have everything I need to graph. So let's graph. All right, so let's graph. So here is my y-axis. I know that my x-axis is going to be my horizontal asymptote. Now, one thing you need to know about horizontal asymptotes only tell us an behavior. You're allowed to pass through a horizontal asymptote as many times as you need to, but it will ultimately tell us how the graph behaves at the very end. All right. So here is y equals 0 or my x-axis. Okay, let's start drawing in some other asymptotes. I know I have an asymptote at -1. So this is going to be x equals -1. I know I have an asymptote at x. I know I have an x and y intercept right here at 0, 0. Now, let's use our behavior to figure out what's actually going on with this graph. So as the limit as x approaches -1 from the left. So as I'm coming to -1 from the left, the graph is going down. So I know my end behavior is pretty close to this asymptote, and it's going to bend down like so. All right. Now, what about as we're coming to -1 from the right? As we're coming from the right, it's going to infinity. So this is bending up, like so. Now, what's happening when we're going to 1 to the left? 1 from the left, we're going back down. So it's doing something like this. And then, as we're going from 1 from the right, it's going up. So it's doing something like this. And there, ladies and gentlemen, is a sketch of my function f, which was 4x over x squared minus. This is roughly what this graph looks like. Just a sketch, not being real precise with it, but I do have my x and y intercepts labeled. I have my horizontal asymptote labeled and done with a dashed line. My vertical asymptotes, I have arrows stating that it's going up and down forever. And voila. I really like graphing these, even though they are a little tedious, because to me, when you start graphing this stuff... Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.